Imagine a world where every text you send, every payment you make, and every private file you upload could be intercepted and read by anyone. That's the world we would live in without cryptography. Today, we're going to break down the 3 core building blocks of modern cryptography: hashing, digital signatures, and public/private keys, in a way that's simple, practical, and actually makes sense. Let's start with hashing. A hash is like a digital fingerprint for data. You give it an input, whether that's a word, a file, or even an entire video, and the hashing algorithm transforms it into a fixed-length string of numbers and letters. For example, the word hello might turn into something like 2CF24DBA5, but if you change just one letter, even from hello to hello, you'll get a completely different hash. Here's why that's powerful. Integrity check hashes help us verify that data hasn't been tampered with. If the hash of a downloaded file matches the original, you know it's authentic. Irreversibility, you can't take a hash and reverse engineer the original data. It's one way. Speed hashing is fast, which makes it perfect for verifying large amounts of data quickly. In simple terms, hashing is about proving data hasn't changed. Now let's talk about digital signatures, the online version of a handwritten signature, but way more secure. A digital signature works like this. You take the data you want to sign, maybe an email or a transaction. You hash it first, so you get that unique fingerprint we just talked about. Then you encrypt that hash with your private key. That encrypted hash is your signature. When someone receives your message, they can use your public key to decrypt the signature and check if the hash matches the data. If it does, 2 things are confirmed. Integrity, the data hasn't been changed. Authenticity, it really came from you, because only you have the private key to create that signature. This is the backbone of trust in the digital world. Without digital signatures, secure emails, blockchain transactions, and software updates would be impossible. Imagine downloading an update for your computer without knowing if it really came from Microsoft or from a hacker. That's the problem signatures solve. Alright, so we've mentioned keys a few times. Let's break them down. In cryptography, we use what's called asymmetric encryption. That means there are 2 keys. A public key, which you can share with anyone. A private key, which you must keep secret. Here's how they work. If someone wants to send you a secret message, they encrypt it using your public key. Only your private key can decrypt it. On the other hand, if you want to prove your identity, you can sign something with your private key, and anyone can verify it with your public key. Think of it like a locked mailbox. The public key is the slot where people drop letters in. Anyone can put something inside. But the private key is the key to open the mailbox and read those letters. This system is what makes secure communication over the internet possible. From WhatsApp chats to online banking, public/private keys ensure privacy and trust. So let's tie it all together. Hashing keeps data intact by creating digital fingerprints. Digital signatures ensure authenticity and integrity, proving who sent a message. Public and private keys form the foundation of secure communication and trust online. Next time you log in, make a payment, or send a message, remember, cryptography is silently working in the background to protect your digital life. If you found this breakdown helpful, hit the like button, subscribe for more deep dives into technology, and drop a comment on what cryptography topic you'd like me to explain next.